Hello, hi. So this is tutorial number 9, okay, on chapter 4. Okay, so basically this is going to cover subtopic 4.3 lah. Okay, so first question, write the expressions for the force acting on an electron carrying a charge E moving with a velocity V. Okay, so basically when talking about electron lah, the charge will be electron. Okay, when it enters perpendicularly, so means that it's 90 degree to the first one is electric field. So dia nak minta expression for the force. So kalau dalam electric field, this is basically in chapter 1 lah. So kita ada apa equation dia? So in the electric field, so it's perpendicular. So Fe equal to QE. So E will be electric field, Q will be the charge, as the charge for electron is E. So kita tukarlah E and capital E. Okay, for second one, a magnetic field of the intensity. Okay, sorry, that's sepatutnya FB. Okay, so this one, FB equal to QVB sin theta. So the charge will be E, V, velocity, B is a magnetic field, and sin theta. So what is the theta there? So sebab dia kata is enters perpendicularly to the magnetic field. So maksudnya velocity awak dengan B ni adalah 90 degree. So Q tu tukar jadi E, VB sin 90 degree. So sin 90 dapat berapa? Dapat 1. Therefore, magnetic force is equal to EVB. Okay? Okay, second one, B. Sketch the two separate diagrams of the directions of field, velocity and path of the electron and the force acting on it for the motion in part A, 1 and 2. Okay, so the first part saya dah lukis dekat situ, kita ada electric field dan kita ada electron. Okay, so basically yang untuk electric field dan kita ada magnetic field. So saya dah lukis ada dekat situ, electric field, electron masuk perpendicular lah 90 degree. So if I said that the top plate adalah positive, bottom plate is negative, so in what direction is the electric field? Ke mana? That will be the line. So the positive, negative, dia ke mana electric field? So gonna directed downwards. Okay, sebab electric field move from higher potential to lower potential. So positive plate tu means that it has higher potential. Right? So it's lower, so dia ke bawah. Okay. So because of electron charge is positive and negative. So the charge will be negative. So negative when attracted to the positive plate. So the Fe will be where? So Fe dia akan ke atas. Okay. So kita ada velocity ke kanan, electric force ke atas. The path will be, so kita ada dua benda tertarik. Satu tarik atas, one tarik ke kanan. So eventually your electron going to move in parabolic path ke atas. Okay, to positive plate lah, because electron is negative charge. Okay, so for the second question dalam magnetic field, okay, so saya buat kat situ, the magnetic field is pangkal, cross magnetic field means that the magnetic field is into the page. Okay, so velocity is to the right. So now we need to determine the directions of force acting on the electron charge. Okay, so what we're going to do is kita akan guna right hand palm rule. Okay, right hand palm rule. Okay, so right hand palm rule kita akan buat untuk charge. So you keluarkan tangan kanan. Okay, so macam kalau saya buat you punya fingers will follow the directions of velocity. Your palm will follow the directions of magnetic field. Okay, so if you look at this, you got to use your right hand. So tetapi my hand is quite superior lah tu. Okay, so your thumb will show the directions of force. So for normal charge, for positive charge, the directions of force, magnetic force will upwards will become upwards because the thumb is pointing upwards. But in this case, because the electron has a negative charge, so the directions of force will be opposite direction to the force that we found. Okay, therefore sebab kita dapat force ke atas, the actual directions of force acting on the electron will be downwards. So FB will be downwards. Okay, same goes as before. Velocity is going to the right. Okay, then FB is to downwards. So the motion will be circular motion. That one will be clockwise. Semi-circular motion. Okay, so for part C, with reference to your diagram, state two differences between the electric field and magnetic field. Okay, so what we're going to do is we make a column, one electric field, another one is magnetic field. So the answer from electric field is the directions of electric force on a position, on a positive charge. Okay, so positive is positive lah. Kata is in the same direction as the electric field. Okay, so kalau kita ada positive charge, positif akan tertarik kepada negatif. So positive, kalau ni electron lah, kalau tu adalah positive charge, what going to happen? Okay, dia akan tertarik kepada negative plate. So force dia ke bawah, Fe ke bawah, so dia akan tertarik kepada sama direction dengan electric field. Okay, so however, for in magnetic field, so in magnetic field, the directions of Fm tu sepatutnya Fbn, magnetic force, the B and velocity are mutually perpendicular to each other. So you can see that as a highlight tu V, Fb dan B adalah 90 darjah to each other. Just that magnetic field tu adalah into the page. So it's basically kalau kita guna X, Y, Z, B tu adalah in Z component. That's why kita boleh guna right hand palm rule. Semua benda adalah 90 degree to each other. Okay, so second one is electric force is independent of the velocity. So dalam, if you look at the above diagram, regardless the directions of velocity, makin laju ke, makin perlahan ke, okay, directions of electric force masih lagi sama. And also, dia punya magnitude pun will remain the same sebab F equal to QE. It depends on the charge and also the strength of electric field only. For in magnetic field, magnetic force is directly proportional to the velocity of the charge. So Fm tu supposed to be Fb lah. So Fb equal to QVB sin theta. So V is the velocity. So if everything else is a constant, Fb is directly proportional with velocity.